All right, so we are going to look at exercise 1.03, number 1. Rational function points of discontinuity. So in each case, we have a trinomial over a trinomial. And we have to classify the points as a zero, a vertical asymptote, or a removable discontinuity. We can't try to solve it simply by graphing. That will make vertical asymptotes clear, but we may run into other issues. It is better to solve them by factoring. Now, a zero is a value that makes the numerator 0, but the denominator remains non-zero. A vertical asymptote is where the denominator equals 0, but the numerator does not. Removable discontinuities occur when both the numerator and the denominator equal 0, but in the factored form, you cancel one of each and you have no such factors remaining. If both are 0, it's ambiguous. That's the only time you can have a removable discontinuity, but it might not stay removed. You might cancel one factor and have another one left behind. So as a quick demonstration, we will graph this one. We see when we have it graphed that we have a 0 at x equals 2, and we have a vertical asymptote at x equals -1. So the vertical asymptote is always going to be the vertical asymptote, but the 2 could be either a 0 or a removable discontinuity. We have to check which. So for that, we will do some algebra. So in this case, we have our x squared minus 4x plus 4 over x squared minus x minus 2. When we fully factor the numerator, we get x minus 2 squared. When we fully factor the denominator, we get x minus 2 times x plus 1. So the x minus 2 term cancels, which means before the cancellation, dividing by 0 would occur when x equals 2. This was a discontinuity, which means our x equals 2 is not just the 0 that we see in the graph, but it is in fact a removable discontinuity. So in all cases, we are going to have to factor completely to be confident in our answer. Again, graphing it will clearly show vertical asymptotes, because that's a discontinuity that has not been removed. But if you have a 0 at that value, you must check to see if it was a removable discontinuity as well. In this case, we have x plus 3 over x squared plus 2x minus 3. So this is x plus 3 over x squared plus 2x minus 3. So our numerator cannot be factored any further. When we're factoring here with multiple choice, we can take a look at the numbers they gave us to look at and see that x plus 1 is a value of interest to them. So that is a strong hint that our denominator is going to factor as that x plus 3 that we see up here, and x minus 1. At the very least, x minus 1, which is not in the numerator, can only be of interest. And when I say of interest, it means it's not a normal point. So it's either a 0 or a vertical asymptote or a removable discontinuity if that factor appears in the denominator. It clearly does not appear in the numerator, so that means it cannot cancel. It's going to end up being a vertical asymptote. But once we know x minus 1 is here, that tells us that because it works out to a -3 constant, we must have a minus 1 times a plus 3 to get that constant. So x plus 3 is our other term. We can quickly multiply that in our heads to get x squared minus x plus 3x, or plus 2x, minus 3. But the key is that the x minus 3, or x equals minus 3, is a removable discontinuity, not just the 0 that we would see from this. So in our next one, we've got 3 points of interest. We have an x squared minus 3x minus 40 and an x squared plus 16x over 64, which we have transcribed here. Now we need to factor numerator and denominator. The denominator perfectly fits that difference of perfect squares form. And our numerator, we need two numbers that multiply out to 40, which when subtracted, because that's a minus sign, gives us a 3. So factors of 40 that are 3 units apart will be 8 and 5, and the 8 has to have the negative sign so that our cross term comes out negative. So these are the points of interest. X equals 8 and x equals negative 5 will both be zeros, while x equals negative 8 from our denominator will be our vertical asymptote, which does not cancel. And now the fourth and final question, x plus 8 over x squared minus 10x plus 9. Now, 8 is not a factor of 9. So this x minus 8 can only be a 0. It cannot make our denominator negative, which is a strong indication that these two are going to be vertical asymptotes since there are no terms left to cancel. Since we know this is a 0, we can even substitute negative 8 in the denominator and get 64 plus 80 plus 9, which is most definitely not 0. It's 3 positive numbers added together. We could do our factoring, which does turn this into x minus 1 times x minus 9, or we could graph it and confirm that both are vertical asymptotes, which we have now quickly done over here, and we do see that vertical asymptote at negative 1 and another vertical asymptote at x equals, sorry, I said negative 1, x equals 1 and x equals 9 are the two vertical asymptotes, confirming these answers. So this concludes the solutions to homework 1.03 number 1.